All right, good morning, everyone. Today we're going to continue our FRQ practice. So this is an example from the same AP exam that we've been working through this week. So this is question number 5. And let's just go ahead and jump right in. So John believes that as he increases his walking speed, his pulse rate will increase. He wants to model this relationship. John records his pulse rate in beats per minute while walking at each of 7 different speeds in miles per hour. A scatter plot and regression output are shown below. So this is just, as we go through these problems, I'd like to just note some things. So since this is the variables plotted here, this is a regular scatter plot with the variables. It's not a residual plot. So just noting those things here. And then they give us a regression output, so hopefully this looks familiar to us. So using the output, write the equation of the fitted regression line. So I know to write an equation, I need the slope and the y-intercept. So the slope is going to be located where it says coefficients, and then wherever the variable is. So this is going to be my slope, and then the constant here, that is going to be my y-intercept. So we have for part A here, y hat is equal to our 63.45 or 457 plus 16.2809 x. And I know it doesn't ask you to describe the variables, but this is a good place to do so because it demonstrates that you know what y hat and x are representing. So we can say this is our equation where y hat is the predicted pulse and x is the speed. So here, I know that x is the speed because that is the variable indicated here. I also know because of my plot, it shows me speed and then y is the pulse. And note that since this is y hat, we are the predicted pulse rather than just the original pulse. So part B, do your estimate of the slope and intercept parameters have meaningful interpretations in the context of the question? If so, provide interpretations in this context. If not, explain why not. So here they're essentially saying interpret the slope and the intercept as long as it makes sense. So a lot of times, not a lot, but sometimes the y-intercept starts at like a negative value for some reason. It's just where the regression is going. And we know that in the context of the problem, we can't have a negative pulse. So that would be a case where it wouldn't have meaningful interpretation, and that's where we would need to explain, well, the y-intercept is negative and we can't have a negative pulse. But in this case, we do have a positive pulse for the y-intercept, so that does make sense in the context of the problem. And usually the slope will also make sense as well. So the y-intercept is really the only one that we should be concerned about. So for part B, we need to interpret the slope and the y-intercept. So the y-intercept here tells us that when x is 0, so when the speed is 0, and then what's our unit here? Miles per hour. The pulse is 63.457 beats per minute. So that's the interpretation for the intercept. So this is what we're used to seeing here, and that's fine. The only thing that I would add to this is just to be explicitly clear that this is the interpretation for the intercept. So we might want to add a line that says the intercept, and then they say the word estimates here, so do your estimates of the slope. So we can say the intercept estimates when the speed is 0 miles per hour, the pulse is 63.457 beats per minute. And that's a perfectly fine interpretation of the y-intercept. So now the slope, so we can say the slope estimates that as our x increases by one value, our y increases by the certain slope value. So we can say the slope estimates that as the speed increases by 1 mile per hour, the pulse increases by, let's see what our pulse was, 16.2809. And then our units are beats per minute. So in this situation here, normally we would write the estimated pulse increases by whatever this may be. But because we use the word estimate to begin with, we don't need to say the predicted pulse or the estimated pulse. We've already said that. So by providing this estimate word here and here, it's already assumed that this is the prediction equation. And then part C says John wants to provide a 98% confidence interval for the slope parameter in his final report. So we want to compute the margin of error that John should use, assume that the conditions have been satisfied. So looking at this problem here, they're only asking us to calculate the margin of error with a 98% confidence level. So that'll help us get our critical value. And we can assume that the conditions have been met, so we don't need to do those conditions here. So the conditions have already been met, we're good to go. The margin of error formula we know is equal to the critical value times the standard deviation of the statistic. So that is going to be, in this problem, since we're dealing with slope, this is going to be a slope regression where we use our coefficient, the standard error of our coefficient of the slope in order to calculate this. So the slope is already calculated for us, or excuse me, the standard error of the slope is already calculated. So this is what I'm going to use in my formula here. So the error is going to be equal to something times this 0.8192. And my critical value that I'm going to use is a t for my critical value. Since this is slope, we're going to use a t. And so I'm just going to put a little c here to indicate that that is a critical value, not a test statistic. So they said that c was equal to 98%. So I need my confidence level, and then I need my degrees of freedom. So I need to be careful here because my degrees of freedom in this problem, since we are dealing with two variables, is n minus 2. So I need to go back to the original problem and I need to see, okay, how many times did he test himself here? Does it say any sort of n value in this problem? So if I look at this, he walks at 7 different speeds. So this is going to be our n. So n is 7 here. So our degrees of freedom is equal to 7 minus 2, which is going to give us 5. So now I need to look at my t-table, and I need to look in row 5 and look for 98%. So row 5, looking across here, and then 98% up here. So we get 3.365 as our T here. So our E is going to be equal to 3.365 times 0.8192. So our margin of error is going to be equal to 2.756. And then we're going to give this a unit here, actually. Let me round correctly. This will be a 7. So 2.757. And then since this is the slope, standard error of the slope, this is going to be measured as our speed. So this is going to be in let me go back. So our speed here is our slope variable. What are they asking us to do here? Interesting. Okay. Sorry, I was looking at the scoring guide and it said that they put this as beats per minute. And I'm not entirely sure why, since I believe that since we're looking at the slope, we would put the variable or the labels for the slope. So I'm going to put this as miles per hour, but I will follow back with this on the Zoom call as to why this is, why they're indicating this as beats per minute when I believe it should be miles per hour. I'll follow back and make sure that we are using this 100% correctly. If you have a compelling reason why we should use one over the other, please follow up with me during our Zoom call and we can debate this. Which one should it be, beats per minute or miles per hour? All right. So now go ahead and complete, or you can start the example FRQ, and then we will meet at 8:20 on the Zoom call. Again, these calls are locked, so make sure that you are logging on at 8:20 so you do not miss our Zoom call, and these are mandatory. All right, have a great rest of your day, everyone.